Developing meaningful cross-curricular links is key on the agenda for the new national curriculum. This presentation will focus on cross-curricular approaches to mathematics and science for primary-age children. It will explore the benefits and limitations, pedagogical decisions, and what links may look like in practice, whilst discussing how ICT tools and educational media can be used to support and enhance learning. The cross-curricular approach has been the subject of debate for a considerable period of time. Within primary education, it has been associated with a more child-centred, constructivist approach, which in the last century was recognised by the Hutto Report 1931 and the Plowden Report 1967. The old national curriculum made topic work difficult as it divided the curriculum into discrete subjects. However, the Rose Review in 2009 stated that effective primary schools were one providing children with rich cross-curricular studies, and it seems a new national curriculum favours this approach. Cross-curricular learning is highly linked to constructivism. Constructivists believe that learning is an active mental process in which connections are made between experience, prior knowledge and new ideas. In relation to theory, this approach would incorporate elements discussed by Bruner. Bruner states that learning is an active social process and children construct new ideas or concepts based on current knowledge. This approach provides students with an engaging learning experience where key skills can be applied across domains. However, the approach can be time-consuming and expertise and resources can become an issue. According to the Plowden Report, children's learning does not fit into neat subject categories, and therefore it is necessary for children to make links across subjects, for example in maths and science. Maths and science contain overlapping themes and skills, however it must not be assumed that children will remember maths skills and draw upon them in science lessons. Alexander, Rose and Woodhead define cross-curricular teaching as a way of organising the curriculum. They state it is frequently inquiry-based and combines elements of different subjects together under a common theme. According to Driscoll et al. 2011, the holistic approach contextualises learning and allows children to make sense of the world in which they live in. Ofsted 2002 recognised that successful primary schools gave children the opportunity to apply skills and knowledge across subjects. Hayes 2010 supports this and says that most effective learning occurs when connections are made and skills gained in one subject reinforce and support the learning of others. Kerry 2011 also favours the approach, stating knowledge is interrelated and individual subjects taught discretely can only give children partial insight to topics. In addition to this, according to Claxton 2002, learning to make links is a key attribute of a good learner. As highlighted by Barnes 2011, cross-curricular work can help children to develop their thinking skills, and Driscoll et al. 2011 recognised that pedagogy of cross-curricular learning enables children to be more active participants. Despite advantages, critics have also raised concerns. Critics argue learning needs to be clearly defined, which is provided through discrete teaching. Greenwood 2013 states that knowledge falls naturally into domains, and a cross-curricular approach causes subjects to lose their identity. Skeptics like Jarvis 2009 and Laurie 2011 recognise that some subjects have overlaps but are often wary as tenuous links can be made, and they believe focus should be on subject content. Weak links should not be made and integrity must not be lost. Poor links can result in superficial learning and cause children to make little progress, as noted by Alexander et al. 1992. Furthermore, Moody's and Reynolds 2011 state the approach lacks rigour and pupils are not able to develop essential subject-specific skills. By linking subjects, assessment of progression can become a concern. Rowley and Cooper 2009 recognised that assessing children's progression of discrete subjects can be difficult when they are taught together, which also raises questions as to whether children can be aware of their individual targets. Alexander 2009 also highlights that poor subject knowledge and lack of pedagogical understanding from teachers can adversely affect the subject content being delivered, therefore impacting upon the quality of cross-curricular learning. Nevertheless, whilst work of Alexander et al. 1992 criticised poorly planned topic work, Kelly and Steed 2012 recognised that their findings also demonstrated that when planning was effective, topic work could be produced to a high standard. Although when in government, this was overlooked and focus was on discrete teaching. Despite criticisms, Barnes 2011 argues that maths is a subject that links to many areas of the curriculum and that links should be developed to enable children the opportunity to practice their math skills. Jarvis 2009 highlights that developing effective cross-curricular links helps children to appreciate the relevance of scientific ideas and skills. There are many connections and applications that link science and mathematics, and integrating the two subjects can help strengthen understanding. This is supported by the National Curriculum 2013. It states in the Mathematics Purpose of Study that maths is essential to everyday life and critical to science. The abstract nature of maths can provide difficulties for children, particularly if they struggle to see the relevance of maths to their everyday lives. Maths therefore requires relevance and contextualisation. Science can provide children with the opportunity to practice maths skills in an engaging and real-life context. Mathematical principles and procedures can be used to help children understand scientific phenomena, and embedding maths skills in science helps aid children's understanding and enthusiasm for a subject. If learning is segregated, children are less able to apply skills to real-life problems. Being able to apply knowledge or the skills learnt is more important and more useful than recalling isolated facts. Activities should help children to understand and find out more about things they have encountered and develop further ideas and skills. The National Curriculum states that children should use and apply their mathematical skills and knowledge to support their understanding of science. It highlights the overlaps of collecting, presenting and analysing data. Statutory requirements for maths in terms of interpreting data are part of the statistics strand and are as follows. They can be found on the DFE website under the Mathematics Programme of Study. To summarise the statutory requirements, the Statistics Unit is introduced in Key Stage 1 and further developed in Key Stage 2. As recognised by the NCETM 2015, young children begin to collect and record data as part of play-based learning. As children learn to interpret a range of graphs and charts, this extends their ability to plan and carry out their own research, and also answer questions of interest, creating their own graphs to support their results. Perhaps this is where the data handling skills learned within mathematics can be applied to other subjects like science, which would be enabled by a cross-curricular approach. The overlap of data handling within science is part of working scientifically, particularly obtaining and presenting scientific evidence, including measuring, observing and recording, and considering evidence and evaluating, therefore drawing conclusions. The highlighted bullet points show statutory requirements that can easily be linked to mathematics. Again, these can be found on the DFE website under the Science Programme of Study. How to gather and record data is progressive, and in Upper Key Stage 2 there is more emphasis on accuracy. Within the science curriculum there are multiple opportunities to link mathematics to science. As discussed by Hiscock 2012, using and applying mathematical skills can be reinforced through the problem-solving, communication and reasoning required in science investigations. If children are involved in gathering data during hands-on science investigations, this active learning can support and help to handling skills, enabling children to meet cross-curricular learning objectives. Easingwood and Williams 2003 recognised that ICT is a tool widely used to enrich teaching and learning within the classroom. ICT software can be useful in supporting cross-curricular links for maths and science. Sensors like data loggers can be used to record scientific phenomena, for example light, sound or temperature, and results can be shown to children live on graphs. Good pedagogy would build upon what children already know and understand, and to children, technology is part of normal everyday routine. There are numerous reasons for using ICT within our classrooms, including motivating students, visually enhancing the learning experience, and facilitating planning. Physically drawing graphs and charts can be quite laborious for children, particularly for those who have poor motor skills. ICT software enables children to retrieve, present, and draw conclusions from data in less time-consuming and more accurate ways. Easingwood and Williams 2004 state that using ICT in this way engages children and promotes high-order thinking skills that support their development. Although this incorporates maths, science and ICT, it may prove quite difficult for Key Stage 1 children, but they could break down the processes and work discreetly, slowly progressing towards linking skills in Key Stage 2. ICT also enables lessons to become multisensory. It allows children to engage with lesson content. Presentations should be simple and focused in order to motivate children, but also be accessible. For example, using blue text on an off-white background can make resources dyslexic friendly, and ICT enables teachers to adapt resources to respond to children's needs. Good practice and pedagogy states that effective planning equips children with the skills to become autonomous learners. Cross-curricular teaching can support the natural links between subjects and help children to understand and further develop ideas and skills they have previously used. Collecting, presenting and analysing data are key components of both mathematics and science, and admittedly, adopting a cross-curricular approach seems beneficial. However, it does not come without its pedagogical and organisational challenges. Constraints include time, resources and subject knowledge. There needs to be effective planning of taught lessons and collaboration between professionals to ensure connections are meaningful. The distinctiveness of individual subjects must not be diminished. A rich cross-curricular environment will help children to answer this question. Linking maths to science makes experiences valid to the learner. Learning is less disjointed and more relevant. Skills can be explored in real contexts, which in turn can promote curiosity and improve motivation. However, to do so effectively, appropriate pedagogical strategies should be developed and policies implemented. Making good links requires thinking, effective planning and collaboration.